Hi, everyone. Good morning. All of you completed the installation of both server client and also downloaded the databases. Can you all confirm, please, that you are ready with the server, client, and also sample databases?
Yes, sir.
Okay, cool then. So I'll just take you through how a database server looks and how the databases look inside that server. Okay. So our client application, you all remember the name of the client application?
Yes, sir. SSMS.
SSMS, perfect. That's our client application. And which server are we using here?
Microsoft Server or 2025 developer option.
Correct, yeah. It is Microsoft SQL Server Developer 2025. Okay. Any idea which variant of SQL we use? Okay. It is TSQL, Transact SQL. Okay. So every server, they use different variants of SQL. As we are using Microsoft SQL Server, we use TSQL, Transact SQL. Okay, so I'll anyways take you through the fundamentals of TSQL also. Okay, here we go. So we're working with a server. A server can have multiple instances, but in our case, we are working with only one instance of the server. Just in case if you have installed the server for multiple times, you will see, the server instances, multiple instances like SQL Server 01, 02, 03. But we don't need multiple instances here. We just need only one instance of the server. And one server instance can have multiple databases. So if you look at your server name, you can see it here in the SSMS in your client application. In my case, I renamed my server name as KK Laptop and the server version is this. And as we just seen here, each server instance, I have one instance of the server and there I can see multiple databases. You see that all these things are databases only. In your case also, you have four databases, but in my case, I have a few more. Basically for the different batches, I have the different batch numbers and the, databases. You see these cylindrical icons there, all of them are databases only, these things. Okay, so these are databases. So multiple databases are there, and you already restored EMP database, restaurant database, and 2025 data warehouse and OLTP, both of them of AdventureWorks. So you have these four, but I have a few more. These are like sample databases. We'll also create in this process. Okay, so we'll be creating, deleting, and so many other things we'll be doing. Okay. Fine. So one server can have multiple databases. So nothing but one server can handle multiple databases. Remember this. In our case, we have four databases. You can check that one here. Right. So how a database looks. A database has physical layer, logical layer, external layer. But again, you don't need to worry about these things because someone who develops the database, they need to take care of this process. What is a data file? What is a log file? What are the tables? What are the queries and views? Anyways, we'll also see them, but we don't need to spend much time there because our job is to do the data extraction. So, so what is a data file, log file? What is a table? Okay, what is a query? What is a view? What is a schema? So many things are there inside the database. I'll take you through one by one. But as I said, database development is not our job. But having some idea about database development is a good thing to have, but not a mandatory one. Okay. So coming to the database objects, each and every database that you see here, once you expand it, you see different sub-object inside. Okay. Broadly, we talk about a primary data file and a log file. At the time of designing the database, I'll show you what is a primary data file and a log file. And we always look at this only the primary data file because this data file only has our required objects like tables and views. You take a look at only the tables and views for now, okay? Indexes, synonyms, and other few things like stored procedures and so many other things are there inside a database. But at this point, only try to understand a table and a view. They are important because that is where we have the required data. Because you know this very well, right? In all these databases, where do we store the data? In tables. So why are we looking at only the tables? Because as a data analyst, my job is to work with the tables and extract the data. What is a view? View is also a table, but which is a virtual table. We'll talk about that. What is a virtual table? Okay, how it helps us to get the data. So view also works as good as a table only, but only for the data extraction we use. At this point, I hope you all are okay with this word table. You don't have any confusion with the table, right? What is a table in Excel? We have seen tables in Excel also. What is a table in Excel?
Combination of rows and columns.
Right, something that has combination of rows and columns. Perfect. And for a table, there are certain rules. Table column headers are mandatory. Headers cannot be duplicated. Certain rules are there. The same rules are followed in SQL as well. We'll talk about that. Okay. So in a database, we focus only on these two things mostly because as a data analyst, our job is to understand all the tables, relationships between the tables. To create the relationships, we already understood where I think we discussed this, right? Yeah, we discussed us already, like primary key, foreign key, how these things help, right? In order to create the relationships. Perfect. Right. I've already checked, what is that? Just take a look at this. I've already discussed this one, like what are the similarities between Excel and SQL. Let us get into T-SQL concepts. One final check. I want you to respond in the chat window if you are ready with your server, client, and sample databases in the in the server. If you are done, I want you to respond in the chat window, say yes there or no there if you are not done. Use the chat window. I want to see the count. I think Samantha, you are the one, right? We did it in your system itself, right?
Yes, sir.
Okay, perfect. So 1, 2, 3. Others? Say yes or no, that's fine. Okay. 4 so far. Okay. 1 no. No. Okay. Yeah. Okay. Fine. So the ones who couldn't complete, requesting you to do it as soon as possible because we are getting into the commands now, and I'll be taking you through a few other type of commands, like especially these DDL, DML commands. Of course, not mandatory for us, but definitely good to know about them. Okay. Because as a data analyst, when you want to retrieve the data, you need to have some idea about how the tables are designed as well. So let us spend some time on the DDL and DML commands as well. In the real time, we don't get any opportunity to work with DDLs and DMLs. We always work with DQLs, data query language commands only. Okay, but it's good to know the DDLs and DMLs. Okay, because at the time of data retrieval, you need to understand how the table is designed. Okay, so with that, I'll just take you through. Anyways, discuss this here. In the instructions, there are 13 rules proposed by A of Code. We discussed that. SQL Server setup is done. Client setup is done. And we also, downloaded a few sample databases and restored them into our server. That is also done. Let us go to the T-SQL concepts. Okay. So what is this T-SQL? T-SQL transact SQL. So far, we have been talking about SQL. Then what is this TSQL? Right? TSQL is one of the variants of SQL. And this is the language from Microsoft SQL Server. So Microsoft SQL Server understands the TSQL. Okay, there you get a question like, how about other servers? So what if it is Oracle? What if it is MySQL server and all? So there you have different variants. Oracle, you usually hear PLSQL. Okay, in MySQL, you have a MySQL language. But I'll tell you one very, very important thing here. All these SQL variants, they look very much similar. Maybe 2 to 3% difference is there, but majority of the codes they look same only, maybe slightly the syntax wise slightly difference may be there, but most of the times we write the same kind of codes right across any kind of a variant of SQL. So you really no need to worry. Even if you learn just TSQL, you will be able to easily understand MySQL codes and PLSQL codes. Okay, so what is TSQL? It's a proprietary procedural language used by Microsoft SQL Server. So what is the language that we use here? SQL only. But if someone asks like what is the variant of SQL we use? TSQL. Even just you learn TSQL, you will be able to understand the other SQLs also, because all those commands, they look very much same, right? It was, originally developed by Sybase. There is another company, Sybase, but now it's owned by Microsoft. But it's been like long back they acquired it. Right. So TSQL is the one that is we are going to use in Microsoft SQL Server. Instead of reading theory, I'll just take you through all the practicals and how we create the databases and what kind of commands are there, right? I'll show you step by step what is a schema, what is a table, right? How to design a table and all. So let's first of all go with creation of the database. But here we go. In order to create the database, the first set of commands that we need to understand. Okay. So let us write, make a note if needed. Otherwise, if you can remember it, also great. There are different types of commands available in SQL. What are they? TDL, DML, DQL, DCL, and TCL. Okay. So DDL, data definition language. This is where we define the things. Okay. This is where we define the things like creating objects, altering the objects, and dropping the objects. So the three commands in DDL are create, alter, drop. Okay, in the DDL we have create, alter, drop. Right. So what is the next one? DML. The DML commands, data manipulation language. There we have insert, update, delete, truncate. Insert, update, delete, truncate. Okay, DML, insert, update, delete, truncate. What is DQL? Data query language. This is where we have only one command, which is select. But along with select, we do so many other things. Like we apply the where clauses, having clauses, group by, sorting, like order by, right? Different kind of things, joins, aggregate functions, and different kind of things. Okay. So DQL, that has only one command, select. DCL, data control language. This is where we grant or revoke permission. So the commands are grant and revoke. Okay, grant or revoke. Last one, TCL, transaction control language. This is where we discuss begin, commit, rollback, save point. Begin, commit, rollback, save point. Okay, done. Here we go. So we are going to discuss all of them, but we spend more time on DQL. Can anyone tell me why we need to spend only more time on DQL? Why not on others?
Because in real time we don't get to work on TDL and DML
Yeah,
or
correct.
mostly at all.
DDL, DML,
We
DCL,
don't.
TCL. In the real
Yeah.
time, we don't use them much. For a fact, we don't get any access also to perform those things. Because as a data analyst, my job is to extract the data, create the reports, draw the insights from the data, help the business. My job is not designing the tables. My job is not load the data into it. Again, we don't do that activity. Okay, even we have access to do that. Our scope clearly says, okay, we are not supposed to touch the raw data. Whatever the way it is, we just simply report it. But if you really see any deviations in the data, we just mention that, okay, something is not looking okay, and please get it corrected from the database side itself. Okay, I can give you a classic example here. One of those teams, we were creating these reports, different kind of analytics we were publishing for them. And the senior manager came back to us saying, okay, one of those numbers looking off. Okay, so it's supposed to be ranging between 5 to 10, but it was showing 150. That's due to a technical glitch. Okay, so that senior manager requested us to fix that report just by writing an exemption there, saying if any transaction ID is coming with so and so ID number, then just to fix the value to change it as 10. That's what that person mentioned. Okay, so that the report will be fixed. Now you tell me, is it okay to write an exemption for only for that transaction ID in the report? Yes or no, to get the report correct? You understood the challenge there? One of those reports we published, okay, and one number looks like 150, but it's supposed to be between 5 to 10 only. Later, they realized it is due to a technical glitch in the system. The number went too high. Now that the team manager reaches out to the analytics team saying, okay, please fix this number because that 150 is actually disturbing all other averages. Please write an kind of an exception there. So and so ID, if it is there, just rewrite it like 10 instead of 150 so that the entire report can be corrected. Is it okay to do that or not? You have access to it, let's assume.
It's okay, but what if some other number is added later?
Yeah, so I'll tell you one thing. We usually don't do the database modifications even if we have the access, and it's supposed to be done by the people who actually manage the database. The reason being, okay, we can simply write one an update query and you go to the transaction ID and you can fix that number. That's okay. But the problem is that you never know how many other tables have the dependencies with this number, right? Because you are not the database developer, you don't know exactly what all will change because of this small modification there. So it is recommended to route that request to the database admin team only, where they can look into it, and if something really went wrong and they can fix it, because they also know what are the other tables have the dependencies with this number. Just by fixing one number may know that may fix one report, but it may disturb other 20 different reports. So just be careful. So that's the reason we do not perform any DMLs and DDLs. Okay, of course we do not get any access also, but just in case, if you have access, if someone asks you to modify as an analytics team member or a reporting team member, we are not supposed to do that. Okay, fine. So proceed with this. Let's proceed with this DDL commands. One of those things is create command. We have the create, alter, drop we discussed, right? I'll go with the create command now. So what is this create command? And especially for the database, I want to create a database, right? So after that, I can create the tables inside and I can store some data inside. Yeah, fine. Here we go. I want to create a database. It is possible in two ways. Way one is you just do a right click on the databases. You can try both of them. Okay. Once you are done with the installation, you can just directly take new database, give a name to it saying B00754 sample database. Okay. So I told you, right? Every database that comes with two files. One is the data file, nothing but the primary data file, and the other one is the log file. Primary data file that holds all the tables, views, synonyms, indexes, and all other stuff. Log, only the log information, like who all accessed and all. And if you look at this initial size of the database, you see this, it's showing 8 MB. And that is not enough actually, right? So 8 MB is what? Nothing. If you are implementing this database for Amazon kind of a company, 8 MB is done in milliseconds because so many transactions they will be placed onto the database, right? So you may require a little more. I'm just taking 1 GB, 1024 MB. And then we have the auto growth and max size. You can set up the properties here. Auto growth, nothing but once it hits that 1 GB, then it automatically increases by more 64 MB. And how long it can go? Maximum file size is unlimited. Nothing but as long as your SSD or hard drive supports that space, it will keep on increasing. Okay, the size will auto increment by 64 MB every time. Once it hits one more 64, again it will increase. Again it will increase. Again it will increase. How much time? How many times? Unlimited. Like as long as your hard disk supports it. Because whatever the database I'm creating, keeping that 1024 MB, nothing but 1 GB space, that will be occupied on my hard disk only or SSD only. And where is it getting saved? Yeah, a default path. I'm okay with that path, okay? So if you want, you can change the path also, but let us leave it to the default path. Microsoft SQL Server has a default path to store all these databases. Click OK. That's it. A new database has been created. You see this? But you get a question, you used user interface to create this one, right? How about if I want to create this by a code, nothing but a SQL query? Here we go. You just need to keep the cursor here on the databases. Take a new query. We can write a query here. Which query is it? Create database. Space database name, right? So the database name I can say B00754 sample DB1. Can anyone tell me why am I typing sample DB1? Why not simply sample DB?
We have
The
already
name
created
is
one with the
existed.
same name.
Yeah, the name is existing there and duplication of the objects is not possible in the database. Right? In the databases or in the name of the database or inside the database, the table names also cannot be duplicated. Everything must be uniquely identified. So that's the reason I'm using this. Right. So create database name. While executing this, I want you to take a look at the query connection. Okay, to which database it is connected. Very, very important. You get a question, what is this query connection? And it is showing master, EMP, and so many things, right? Okay, let me explain it. If I select EMP database and if I take a new query, observe this carefully, then the new query is connected to EMP database, nothing but this, so that I can perform anything on this EMP database because it is connected to EMP database. The query connection to which database it is connected is very, very important to check before executing things. I'll tell you why. If I write a query here, just only for your understanding purpose, I'm writing select star from employee. You may get so many questions there. What is that employee and all? That's fine. Select star from employee. I got some output there, right? But same thing, if I select restaurant database and if I take the new query and I type the same query, execute it, I'll get an error. That means your query instance is connected to a database. That database should have these tables, right? So in the restaurant database, there is no employee table. That is the reason it is failing. But in the employee database, there is an employee table. That is the reason I'm able to get some output. So that means which database it is pointing to matters a lot at the time of executing the query, right? So at the time of selecting the query, new query itself, you need to make sure on which database you want to trigger. So when I kept the cursor on the databases and I took this new query, it by default points to master database, and that is what we need because we want to create a new database. Okay. So sometimes what happens is that, let me show you. Let me just take a new query. And let's assume that I took a new query on the EMP database. Okay, now it is pointing to EMP database. But what you can do, in order to execute this on the master database, you can use this command like use master go, right? Optional thing only. But when it becomes mandatory, if your query connection is pointing to something else, but you need to trigger this query on the master database, then you need to use master go. And if you execute it, observe the query instance, that will automatically change to master. Then I can write, that create database name is there, right? So I can do that here. So basically, what I'm trying to show you here, when you try to create a new query, make sure, first of all, on which database your cursor is there or selection is there, right? Basis on that only a new query instance will be created. But after that, if you want to move to any of the other databases, you can write these things. Let's say if I want to go to the EMP database, okay, use EMP Go. If I do that, it will point to EMP. You see that? Right. So this is kind of an optional thing at this point for me because I'm in this query instance. In this query instance, I'm already there where on the master only. But just in case if it is not there, what is the line that I need to use? Use master go. So first line, it will take, I mean, the first two lines, they will take me to the master database and then it will trigger the new database, create database command. But here I no need to write it. Okay, because it's already pointing to master. If I execute this now, then a new database will be created. There you should get a question. Yeah, okay, new database will be created, but how about the size of the database? How about auto growth of the database? How about maximum size of the database? How about what is the name used, where it is saved? Because when I created the database using this user interface, I was able to see all those different properties. But you are not writing anything, and how can you execute like this, right? There is no maximum size, there is no database size. Here we go. If I directly execute like this also, it will work using all the default settings. When I take a new database, it is already coming up with this 8 MB, 8 MB and all that stuff, right? So it goes with the same default settings and the name is going to be this one. Anyways, I gave the name here, right? But just in case if you want to write all of those properties, create database, database name is okay, but the rest of the things are kind of optional for you. On what is the name of that file name, where it should be saved, what is the size of the database, what is the maximum size it can go up to, what is the auto growth, how much MB it should increase every time, and this is your data file. And you know that, right? Every database has two files, primary data file and a log file. And how about the log? Log name is this and log should be saved here. The size is this, maximum size is this, and file growth is this. You will have to write all of them. But again, database designing or creation of the database is not our job. So even if you do not focus there, that's okay. Let us execute this command to get a new database. Commands completed successfully, and 754 sample DB1 should come there. And if you look at the Object Explorer, do you see that new database there? Check. Is it there?
It's not showing up there.
It's not showing it up there, right? Correct. Here we go. In the pivot table also, if you do certain modifications in the data, what is that you need to do on the pivot table if you want to see those modifications?
Refresh.
Correct. I just need to do a on the databases folder. If I just do a refresh, the database one will come there. You see that? Is that fine?
Yes, got it.
Okay, so we are able to create the database. Great. There is alteration of the database. Let's not get into that alteration at this point. Well, we'll anyway see that altering the tables and all, alteration of the database, we don't do much. But let us see the next command. Create is to create the object. Alter is to modify something in the database, something like, you created a database with 10 MB. Later you realize like, okay, 10 MB is not enough. You want to get at least 1 GB. Then you need to do what? Alter the settings, right? Alter the settings of the database. Like you need to change the size, alter the size to 1024. Alteration is possible, but we don't do much. Okay. So the next one is drop database. You don't want this database anymore in the server. What you can do is same command. This time it is drop database name. That's it. Okay. Observe something this time. In this query instance, I have two commands, but I'm selecting only one command and I want to execute that. Okay, selecting only one command and I want to execute that. Then what will happen here, whenever you select some part of the commands, okay, a few lines of the commands, only those selected lines are executed. Remember this. So that's the reason most of the SQL developers, whenever they execute it, right? I mean, it turns out to be like a kind of a habit, okay? So you see this, even though it has only one line, and I know that, there is only one line, but usually what happens is that before executing it, we just select it. Even if you do not select it also, it will execute only one line. But it comes like a practice, whenever we want to execute a certain line of code, we just select only that line of code and execute that. That's it, command successful, and I still see that, but I've dropped it. Drop is nothing but permanently delete that object from the server. But I still see that. What could be the reason?
Same thing, we need to refresh.
Yeah, I just need to do a refresh. Go to the databases folder, do a refresh. That's it, it's gone. Right? We are left with only one there. Okay, done. So we understood how to create. Alter I did not discuss, but drop, how to drop it. Nothing but permanently delete it. Okay. Now, let me show you what is schema. You understood what is database, right? All these icons, they show the databases only. Let me show you a schema inside a database, especially in the tables I'll show. It's very important for us to understand the hierarchy here of these objects, okay? All right, let's take a look at this now. Server is this. We understood one server can have multiple databases, right? One of those databases is this. Right? The rest of the database is also there below, but I expanded this, right? We are able to see only one. So we have a server and that server has so many databases. One of the databases is this. So this database contains so many sub-objects, right? Especially one of those sub-objects is something like tables. And these tables have, the table names here. You see that? These all are the table names. But observe something, all these table names are starting with something dot something, right? Let's see that. Human resources dot department, right? What is this human resources from here to here? What is this human resources? This human resources is a schema. Okay, that is a schema. So what is a schema? Schema is a group of related objects. Okay, schema is a group of related objects. And what is the next part here? This is actually the table. Okay, so that is a table. So a table is part of a schema usually. Okay, so you get a question, why do I need to create the schemas, right, for these tables? Without the schemas, can't the tables exist? Yes, they can exist. But the thing is that even if you do not create a schema, all these tables, they fall into a default schema called DBO. That is a default schema. So that means if you do not write any schema name, something like human resource or person or something, then what happens is that they go to the default schemas. What is it? DBO is the default schema. That's all okay. I understand that, these all are looking like a group of tables. They fall under one schema. I understand that. But what is the point of creating a schema? Here we go. I'll show you a simple example with the folders here. When you got this material package, you got like so many folders, so many subfolders, so many files inside, right? I get a question here. I just, created course contents, databases, exercises, queries, query levels, and different subfolders I created. Tell me something. Why can't I keep everything in a single folder and share with you all the files with you in one folder? Why I had to create all these subfolders there? Any idea?
It will be quite confusing. You'll not be able to find
For
which
easy
file is
understanding.
related to what topic.
Correct. Easy understanding and which file belongs to which topic. Very hard to find out. And if all the files are there in one folder itself, going to that navigation becomes very very complex, right? Yeah, but if we manage or organize all those files in the folders, then what is the advantage here? Simple. If you want to go to the query levels and you want to discuss a query levels topic, okay, you directly go to that folder. And you want to see the sample queries, okay, you go to that one. If you want to see the sample images there, okay, you go to that one, right? And if you want to see the databases, yeah, you just go there, you have all the databases. See the same purpose, like why we create a folder. Folder is also a logical group. It doesn't occupy any additional space, but in terms of the path, it is easy for us to navigate. Schema does the same thing. What is a schema? Now you can easily understand. It's a logical group. Okay. So what it does, schemas to logically group the tables and other database objects, and DBO is the default schema. That is nothing but if you do not define any schema for a table, that falls in the DBO schema. Okay, if not specified, there will be a DBO schema created. Each schema can have related tables and permissions can be given based on the schema. Okay, let's try to understand. In Google Drive also you received this material, right? Yes. So you tell me, going to each and every file and giving access to you is better, or doing a folder level permissions is better? Which one? If I need to share with you, I can do in two ways. I can go to each and every file, right click, share with one user, right? One file, go back, one more, right click, share with one user. It's the same user, right click, share it, right click, share it, right click, share it. That is better. Or granting the permissions on the folder level is better. Which one?
Folder level is better.
Folder level, perfect. So the schema also does the same thing. Because we have the schemas, they are logically grouping our objects, something like this. If a human resource person, HR department person is there, then on the human resource schema, I can grant access to that person so that person can access all the tables that are there inside human resource. So schema level permissions can be given. That is the advantage of it, right? So what is the default schema? DBO. Why do we create the schemas? To logically group them. What is the purpose? Because we want to manage the group, okay, at a schema level so that, permissions can be given easily, right? And also it is easy for us to navigate. Let's say human resources tables are part of human resources schema. Person related details are part of person schema. Production related details are all the tables are part of production schema. Purchase, yes, purchase schema. Sales schema. You see that, sales has a customer table, sales has a credit card table, sales has an order detail table. Yeah, all of them, they belong to sales. So it is easy for us to navigate. Without the schemas also you can work, but most of the times as a good, best practice, what these developers do, they keep the schemas also. Under that, they keep the tables. Advantage is easy to access, easy to navigate. Done? Got some idea what is a schema? For the schema also you can say create
Yes.
schema name is sales. Done. Let us spend some time understanding the table. Tables are not new. Tables we have seen in Excel also, right? If someone has completed Power BI, you have seen Power BI also tables only there. Right. What is a table? Easy thing, right? Something that has rows and columns. You may want to go through this, theory, but simple answer is something that has rows and columns with valid column headers. It's a table, right? In order to design the table, there are certain rules we need to follow. Okay. In Excel, in order to create a table, it's like very easy, right? In Excel, you just open an Excel blank file and, a blank workbook, right? And you just type whatever the headers you want. It's up to you. Like, you can say EMPID, name, right? And salary, department, right? Location. You can just create it. And let's say department, you want to rename this as department. It's like very easy in Excel that you can add something, you can delete something, because Excel gives us that flexibility. But in the real time, especially a SQL table, it's not that easy. You cannot randomly create the tables, okay? There has to be a lot of, background work to be done before creating any kind of a table inside the database. because table is the one that is to store the data, right? And what all data points needed for that business. A lot of discussions that take place, and what kind of subtables, other dimension tables, fact tables, what all we need to create, how these things to be connected, how these numbers will be useful in the reporting. So many things, they will come in the discussion, right? Yeah. So we understand a table, but how to create a table, I'll show you. Here we go. The next one, what is a column? Column means a vertical entity like this that shows the data of different people in this, different employees, right? But that has the same data type there. So if you take the job column, so what is that you see everywhere? It is text only, but that job belongs to different employees, a vertical entity. Then what is a record? It's a row. By the way, Excel terminology, SQL terminology is little different in the table. Table, we call it table only. When it comes to a column, here in the database side, we call it a field. Okay, employee number field. If I say, that means I'm pointing to employee number column. Field is a column, right? And then what is a row? In Excel, we call it a row, right? The horizontal entity, we call it a record. One record contains the data belongs to one person or one employee, right? Vertical ones are columns, horizontal ones are rows in Excel. Same thing. Vertical ones are fields, horizontal ones are records in SQL. Right. So, you get a question in Excel. It's like very easy, right? Why are you saying SQL or table creation is a little, you know, kind of complex? Because a table that holds a lot of data, and each and every column that you take there, that should add some value to the business. You cannot randomly create the columns, okay? It is not like that, you just go here in Excel. If you feel like, okay, any column is not adding up value, just go there and simply delete it. No, in the production database, deleting or creating a new column is not that easy, okay? So there has to be a business, kind of justification in order to do all that, right? So it's definitely going to be little complex in designing the tables, because we need to consider all other table designs also before creating one more table, how it is going to add more value to the business. But we understood a table means with rows and columns. Columns are fields, rows and records. We know horizontal one, vertical ones and all, right? So let us now go to these things. I'll just take you through a table design now. So in order to create a table, we need a database. Do we have a database? Yes, we have a database. What is a database? Just now I created a sample database for this group. Inside this database, I'm going to create a table, right? So this table, I want to create with the help of a SQL query only. Okay. So what is the create table command? How to do that? Okay. So let us see this. I see one error there. Related instance specific. It looks like your SQL server is not running. You need to go to SQL Server Manager. We discussed this point, right?
Yes, sir.
So there you choose.
I forgot the options, sir. Where I have to go in SQL
So just
in
go to
that,
the
sir?
Start button. Search for SQL
Start.
Server configuration. This one, SQL Server Manager or SQL Server configuration something.
Yeah, configuration manager.
Right. Open that.
Yes, sir.
There your server may be
And
in the
first option
stop.
is SQL Server.
Correct.
Yeah,
Is it?
stopped, sir. It's
Right
stopped.
click and start it.
Okay, sir. Thank you, sir. Thank you so much.
Right. Yeah. So here we go. We want to create the table. So for the table, I'll show the query anyways, but I'll just show all those things in Excel first. Okay, the query looks like this. Okay, so I'll just write that in Excel. Okay, let's assume if I want to create the same table in SQL, what all I need to do, this is what I need to do. Create table, table name, right? create table name, bracket. And in the next lines, I need to write like this. Column name, data type, and constraint. That is the first one, comma. Same way, column name, data type, constraint, comma. Same way again, column name, data type, constraint, so on, so many columns, and then finally close the bracket. Okay, so let me just apply the same format here. Okay, so let's try to understand what are these things. Okay, create table name, column name, data type, and constraint. So let's talk about, first of all, column name. Okay, rules for the column name. See, this column name, you can use different techniques here. You can give any column name, no doubt, but certain rules to be followed at the time of giving the column names to the table, the table column headers. Okay. So we usually go with underscore in the column name. Example is, let's say employee name. If I want to write, I can write EMP underscore name. Okay. Like this. Or we use a camel case. Nothing but without that underscore, we can write something like this also. Okay. But if you really want to use a space in the column name, then the column name will have to be like this, EMP name, like this. So understand that if you want to use a space, what becomes mandatory there? The square brackets become mandatory. So that is the reason it is always recommended not to use a space, because this will increase our the typing effort. Every time you need to remember to type that column name must be within that square brackets. We need to remember that, right? So to avoid that, what do? We usually go with the camel case or underscore, right? So you take any real-time databases, that is the reason you do not see the spaces in the column headers. You observe that any table you export from any application, right? You see all these column headers, they come with underscores usually. Because if the space is there, every column which has a space, we need to write within the square brackets. That will increase the typing effort every time, right? So if I want to create the column names, I'll show it here first. Consider this is an employee table. I want to create the same table in SQL. Then first part is what? In the table creation, the first part is column name to follow these three rules. So look at this one. So can anyone identify what kind of a technique I used here out of these three? EMP ID.
Camel case.
Camel
Camel
case.
case. Okay, done. So I'll be using the same camel case. The first part is the column name, right? So this one, done. How about this ename? So regular casing only I used. Ename like this. That's fine. Job ID. Okay, you tell me. What is that I need to do with this?
It should be given square brackets.
Correct. We need to use the square brackets there because it has a space in it. Right? We use the square brackets. Job ID. Done because it has a space. DEPT ID. That is with the camel case again. Salary, you don't have any problem there because it is a single word, salary. DOJ, no problem. So let's write that DOJ. It's completely lowercase, no problem. Commission, yeah. Gender ID. Again, there is a problem, right? What is it? It has a space. So make sure you write gender ID like this. PAN, no issues. Location. Age. Right. Let me give the definitions for these tables also. The EPT ID. Here it is name and it represents department name basically, but I just simply put it as a name only. Then it is department location. Job ID, again, the same thing. It has a space, so I'll have to use job ID here. Job pay grade. Pay grade also has the space in it, so make sure you write square brackets. Gender ID, same issue. We have the space. And gender. Okay, done. Looks good. All of them, as long as the column names are considered. Okay. The next one is data type. Okay. So what kind of data types we have? We have the binary data types. Okay, we'll talk about that. What is a binary data type? We have the text data type. We have the number data type. But, I'm writing them in the simple English, but in SQL, the data types are little different. Okay, we have the date, time data types and all. Okay, so let us see the different data types now in order to create the table. Binary data type. Binary data type, it is basically to store those images, pictures and all, and bit and binary are there. Bit that stores only 0, 1 null. Okay, three different values, 0, 1 null. Binary, that stores like, different size of the data can be stored there. We usually don't go with that because we usually work with these text numbers and all. So when it comes to the second one, numbers, okay, this is where we need to spend some time. Numeric data type. Okay. In the numeric data type, we have the different data types there. We have big integer, small integer, tiny integer, money, small money, decimal. Different data types are there. Okay, different values range can be stored there, right? Here we go. Big integer, small integer, tiny integer, they all hold whole numbers. You know the difference between whole number and a decimal number, right? Whole number means a rounded number. It doesn't have any kind of decimal points, but the decimal values are also there. They can be stored either with the decimal data type or money, small money also they handle the decimal types. Okay, then this looks good. Now I get a question. All of you take a look at the employee ID column and I want you to suggest which data type is recommended for that column. You want me to go with a big integer, small integer, tiny integer. Look at the numbers here and you suggest which data type is recommended. You see these numbers? Okay. Can I go with big integer? No. Why
Tiny
no?
integer.
Yeah, which one?
Tiny
Tiny integer. Okay. Let's take a tiny integer. But if I define this column, the second part after the column name, the second part is data type, right? If I define this column with the data type tiny integer, what is the maximum capacity that a tiny integer can take up to? 255. You see that? That means what is the maximum number you can input here? 255 only. But if you look at your job IDs, they are into thousands. So tiny integer is not recommended. Now you suggest. Which one is recommended? You understand the problem here, right? So if you want
All
to,
money, I think so.
okay, so are we employee IDs should they be with the money format or number format only? Whole numbers only.
Mm,
See, these are IDs, right? IDs in the numerical data, correct?
Yes.
They are what? What is the maximum number that you see in this column?
7,935.
Correct. If a new employee joins, what would be that person's ID?
7,936.
Right, 7936. So it keeps on increasing like that, right? As and when a new employee joins. So now you tell me which data type can handle thousands of numbers. So definitely that is not money. We don't need the decimal points there.
Small int
Employee,
maybe.
which one?
Small int.
Right, small integer. You can go with small integer, but
Mm.
it is going to handle up to 32,767 ID, correct?
Yes.
Looking at this data, we are in 7,000. I think, yeah, reaching 32,000 will take definitely some time. But just in case, if you want to think about future also, that if it goes beyond that, then what is the data type you can go with?
Int.
Integer data type you can go with. So either small integer or integer data type I can go with. But here I'll go with integer data type, assuming that the employees count will go beyond that 32,000. Because if I define this as a small integer, what is the maximum number that I can type in this column? 32,767 only. What
Yes.
if all the employees joined and one more new employee coming? Then I need to type what? 32,768. Will it accept? No. Why? If I take it like a small integer. You understood the point?
Yes. Got
Done.
it.
So what is the next one? Let us take a look at the other numbers also. Okay, you tell me job ID is there. Which one is suggested here out of all of that? Job ID. Look at the minimum maximum numbers and suggest which data type you suggest from this table. What is the minimum number and maximum number in this column?
7.
Maximum, yes. Which one is okay?
Tiny int we can take.
Correct. We
Because
can
this
go with
is
the
the
tiny
same.
integer because the tiny integer capacity is up to 255, 0 to 255. So definitely it can accommodate 1, 2, 3, 4, 5, 6, 7, right? Because it can go up to 255. So I can go with what? The data type, the second part is tiny integer. Done. Tell me the department ID. Department ID, the maximum value that we have is, up to 50. If it is only just up to 50, which data type you suggest?
Same tiny int.
Same tiny integer, yes. Okay, salary. Same tiny integer is okay, right?
No.
Okay, why no?
Because salary it can be increased, right?
Right,
It's
shall we
the
go with small
money.
integer?
It's in the money.
Right, we can go with money, but let's assume that we don't need to deal with the decimals. We all have the rounded numbers, whole numbers only. This can handle the decimals also. I don't want to use the decimals there. Let's go with any of these things. Okay, which one you all suggest? If I ask you to pick up only from these four, which one you suggest?
Int.
Integer, okay, why not small integer?
It is above. It may go high also, right?
Yeah, so if I define this column as a small integer, then what is the maximum salary number that I can input here? Only 32,767. But I have 50,000 there, 60,000 there. So these numbers cannot be stored, right? So what is the data type I need to take here? Integer, but otherwise, we can go with the money. Okay. That includes the decimals also. Done. DOJ boss. Okay. Coming to boss. Okay. Tell me this. What do you think? Which data type is recommended?
Int.
Yeah, I can go with int only here, integer only, because if you look at your employee IDs, what is the data type I chose there? Integer. Boss is also part of employee table only, right? If you take 1001 boss ID, who is 1001? Mahesh. Mahesh is already part of the same table, right? So whatever the data type I chose here, the same data type will be applicable here as well, because boss is also part of that employee table with an employee ID. Right, okay. Take a look at the commission and suggest which data type is recommended. It is there in a few hundreds.
Mm.
400, 1400, 300, right? Which data type is recommended here?
Tiny int.
Tiny integer.
400, 100, not.
Yeah, I can go with the tiny integer because it's not into so many thousands. Okay. Tell me this gender ID, which one you suggest? You have the 1 and 2 values only. 1, 2.
Again, the
Tiny.
tiny int.
Yeah, for this also you can go with the tiny integer. Yeah. Age. Can I go with integer? Age in years, if I want to write, which data type is recommended there?
Tiny int will be.
Can't we
Tiny
go with
integer.
tiny?
Why tiny integer only? Why not integer or a small
Oh,
integer?
why? Because they're about
Because
30 to 1000,
Hmm.
whereas tiny is up to 256
Right, 255.
to 5. So
Yeah.
that's good for
so age will
That
not
is enough for
range
age,
from.
right? Yeah. So
mm,
255 years is like impossible, right? And maybe 100 or maybe 80, 90, all those numbers can be handled using that tiny integers.
mm.
Right. You get a question. I mean, I have a question. Answer this, please. Instead of going with the specific data types like sometimes small integer, sometimes tiny integer, sometimes integer, right? Actually, big integer can handle all those numbers, right? Right from the smallest numbers to the highest numbers. Yes or no?
Yes.
Why can't I take big integer every time for all the columns then?
Like it consume more space, like data.
Yeah, it consumes more space. Whenever you define a column with big integer, it consumes 8 bytes of data. The rest of the things are like this, okay? Done. Here we go. How does it matter? Like 8 bytes. We are living in the world of terabytes, right? How does it really matter? 8 bytes, right? Yes or no? Maybe
Yes.
for one record, one cell, 8 bytes may not matter much. But imagine if we take incorrectly the big integer data type where it can be accommodated just in tiny integer. But if I define that as a big integer, what is the difference? 7 bytes. Nothing but every cell consumes additional 7 bytes. 7 bytes only, right? How does it matter? Every cell consumes, if you look at a single cell, it's okay. 7 bytes, it doesn't matter. But how about 1 million cells? Nothing but 7 million bytes extra. How about 1 billion cells? That means 7 billion bytes extra. So be careful while choosing the data types. Again, you don't need to worry because this is a job of the database developers who develop the tables. They take care of this. But knowing the data type is very much important for us as a data analyst. Because when you start writing these calculations and all, what do you need? You need the data types only, right? Sometimes you work with numbers, sometimes you work with text to analyze it. So definitely you need to understand the data type of that column. Right now you understand why do we go with specific types only? Why can't we take every time a randomly, something like a big integer, right? It is always recommended to go with the specific type. Okay, here I want to go with a tiny integer. I'm just giving the data types here as well. This is also a tiny integer. This is also a tiny integer. Done. So number data types are we good? We have big integer, small integer, tiny integer, money, small money, decimals. Okay, decimals and this money, small money depends on the requirement we use it. Same like they are also numbers, but they are capable of handling decimals also. Okay, can you tell me an example of where the decimals come into picture? Where do you see the
Percentages,
decimals? Percentages, okay. Any other?
money also sometimes.
Anything related to the sales and all, we get this decimal points at the end, right?
Yes.
Yeah. Okay.
Yeah.
Done. So the next one, the next data type is string or text data type. Strings are text, both of them are like for the text only. Strings we call them, text we call them, depends on the type of tool we use. String is nothing but alphanumeric data only, some text content. So we have char, unchar, varchar, and varchar. Most commonly used one is nvarchar. Okay, so that stores variable length as well, Unicode string data. So basically, all those alphabet special characters that we have, right? A, B, C, Ds are 1, 2, 3, 4 are those symbols, percentage symbols, dollar symbols, star symbols, ampersand symbols, right? Hyphens, underscores, all that data can be stored inside this nvarchar. So what is that nvarchar? Store variable length. Very, very important to understand. Okay. Yeah. Here we go. What is this nvarchar and how it is useful? Take a look at this data. Employee name. Can I take it like integer? Data type. Is it okay?
No.
Why no?
Like numbers are integers, right? Character is.
Correct. Employee name, we expect the text content, some string content to be there, not like numbers there. Correct? Then we go with what? Nvarchar. Okay, nvarchar, and that stores the variable length. Nothing but I want to use, let's say, 50 characters. Okay, you can define the length of the text. 50 characters length should be stored. Okay, that is the maximum allowed there. Okay, if you do not give any number there, by default it goes with one character, but I want to store with what? 50 characters. Okay, why am I taking 50 characters there for the employee name? My assumption is that all the employee names can be accommodated within that. Each and every cell can have 50 characters length, and 50 characters looks like very much enough, right? For the employee name. Is it okay?
Yes.
Right, okay. But you get a question, what if an employee has a bit bigger name? Then here's the catch. To store the data, I don't have any issue storing it with 100 characters also, no problem. But the problem comes when, a simple example. Let's say you have a score sheet or a certificate, right? A intermediate, a 10th, a degree, or a PG. So every certificate has certain template, and in that template, you have a placeholder to print your name there. If someone's name is too big, then what they usually request is they request for an alias name or a short name. The reason being, one thing definitely they can store it inside the database, no problem. Even if I keep it like 100 characters, it will store it. But at the time of printing, it will overlap the other content, right? Because in a certificate template, you have only limited amount of space. Not only that, your passport, let's say Indian passport, if you take that has almost every passport has a similar kind of dimensions, you have only limited amount of space to type your name, right? So understand, in order to store the data, we don't have any problem. But whatever the value that you store inside, when you want to print it, if it is beyond the template space, then printing that such lengthy name on the template is not possible. That is the reason we set limits there. Okay. So nvarchar 50, why am I saying every employee name can go up to 50 characters? Then when I want to use the same name on a payslip, because payslip has a certain format, right? So it won't disturb the other layout. Understood? Right, 50 characters. And any other data column that requires this. Okay, any other things that you can identify here where it requires nvarchar data type? Employee name,
And
okay.
Pan. Can't. Pan.
And okay, fine. Yes, it is alphanumeric data, which is nvarchar. Okay, what is the length you want to give there?
10.
Perfect, because every pan has only 10. Right, location is also nvarchar. And I'll go with 25 characters for the location name. Okay. Yeah, department name, yes, nvarchar, because it is a name, I'll go with 25 characters. Location of the department, yes, this is also nvarchar with 25. Job, yes, it is nvarchar, which may be 20. You tell me, pay grade.
1.
Yeah, one character length is enough. Yeah, gender,
1.
perfect. Done. So text data types also we understood. We usually go with this nvarchar only. There is one more data type, date time data type. You can go with the date alone, time alone, or date time two also. Different formats are there for the date time, like it shows MMDDYY, DDMMYY, DD/MM/YY, right? DD-MM-YY. Different formats. You don't need to worry about them at this point. These are just only the formats of the date and time. but you need to worry about only the data type for now, right? Three data types: date, time, to date, and time. That's what we use. You look at this entire table. Do you see any date column there that requires a date data type?
Date of joining.
Correct, date of joining. And this one, I need to take it as date. Okay. So you can also take date time there, but we don't have time because just like date of joining, we just need only the date. So if you look at all the columns, we were able to successfully, assign the column name and the data type to it, each and every column. The last one is there. What is it? Constraint. Okay. Different types of constraints are there. Something like not null constraint, default constraint. We have check constraint, we have primary key constraint, we have foreign key constraint, we have unique key constraint, we have index as a constraint. Okay. Right. Different types of constraints are there after the data types. Okay. So we need to understand these things. Okay. I'll explain a few things today, and we need to spend some more time on other few constraints. Let's go with the not null constraint. How does it sound? Okay. Basically, what is a constraint? Constraint is a rule enforced on the column. Okay. So a column needs to follow certain rules. So in the form of a constraint, we enforce them. Okay. So if I apply certain constraint, the column must need to obey the rules before accepting the data. Okay. These are used to limit the type of the data that can go into the table, ensures the accuracy and the reliability of the data in the database. Constraints are applicable at a column level or a table level. It's up to us how you want to apply. At this point, we are looking at all these constraints at the column level. The very first constraint are the rule, not null constraint. What is this not null? As the name says, not null. Okay. The best example is I'll go with this employee name. Okay. I'll go with this employee name and tell me an employee name. Can it be null?
No, it can't.
No.
So that means I can apply a not null constraint on this because I know that, employee name cannot be null at the time of entering the data. I cannot onboard an employee without the name, right? So that means employee name cannot be null. Okay, right. By the way, constraints are optional, right? We want to enforce the rules, but not on every column. Not every column, you need to follow that. Right? Yeah. So let's say location column is there. Location column, an employee says, I'm currently here, but I'll be moving to a different location soon. So I'll submit that later. Okay. Is it okay to onboard that employee?
Yes,
Yeah,
we can do
it's
that.
okay because location will be updated later. But without the name, you cannot onboard the employee. But location, you can leave it null there, right? So that means what I'm trying to say is depends on the business. There are certain things they are optional, right? It's not mandatory to insert that record. So location, if you want to leave that constraint part here, I'm not writing any constraint. I want to leave the constraint as an optional one. I can leave it. I don't need to write any constraint there. I'm just, I'm okay with that column header and the data type. Constraint is always an optional thing, right? I can skip that. But certain things you cannot, right? So not null constraint, I'll apply here also. Okay. For the job also, yes, if there is a job ID and you want to show there is a job, right? So it's a not null constraint. Again, gender also, it is a not null constraint, right? Yeah, pay grade, not null constraint, I can apply. So whenever you say something like not null, if you want to insert that record into the table, there must be a value, right? So I'll say this one also not null constraint. Okay. So you understood what is a not null constraint? make
Yes.
sure that if you are inserting a new record here, there must be a value. Then only you can insert. Right, okay. Pan, can I apply a not null constraint? Yes or no?
Yes.
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 Not null constraint, is it fine? Okay, when I enforce the not null constraint on this, let me tell you what happens. When I want to onboard an employee, nothing but I'm taking a new employee record here, and that employee says like, okay, I don't have a PAN. Is it possible? An
Yes.
employee without a PAN, is it possible?
If they are applying, it's okay.
Yeah, it is possible. Like later he might apply and get it. So we can onboard him.
Hmm. Let's say that person got selected, and now we are onboarding that person, and we are entering that person's record, and that person says, I don't have a PAN. Can we stop the onboarding process because there is no PAN?
No, we can't do that
We can
because
still proceed, right? But we request that person to
yes,
submit the PAN as soon as
application and
possible.
get the PAN. Yeah.
Otherwise, there will be a TDS flat 20% something is there. There is a rule applicable. And yeah, without the PAN, the TDS will be done. Done? Yeah, so that means PAN, you cannot enforce a not null constraint. So that means if you enforce a not null constraint, you cannot onboard any employee who doesn't have a PAN. Now you understand the point. So not null constraint, you need to be really careful. You need to check whether is it like mandatory thing to, onboard that person, or is it kind of an optional thing, right? If it is an optional thing, do not enforce the not null constraint there because it makes it mandatory to input something in that column. If you say not null, understood? It turns out to be like a mandatory column to input something there. Is it fine? Now you understood what is not null column?
Yes.
Yes.
Done. There is a default constraint. What is this default constraint? Default constraint means if you leave it blank, if none is specified, it will print a default value. I'll show you what is a default constraint on the location one, okay? So on here, I want to enforce a default constraint, okay? If I take the default constraint like this, what does it mean? Any guess? Just now,
Like it is applicable for the entire, for all the employee IDs, it's Hyderabad.
Means if you type, let's say Vizag, it takes it Vizag. But if you leave it null, you know what it does? It prints by default Hyderabad there. So that nothing but if you type a location name there, it takes the location from the user. But if you intentionally skip that one, then what it prints there? Default value Hyderabad, it prints there. You understood? Certain things we expect this way, right? If you leave a particular thing blank and it goes with what? The default value. Right? So a simple example, your business is operating from India location only India, and you rolled out a form to fill your details, right? And as all the employees are from India, you really no need to ask for their location. But just in case, if anyone wants to write any other location, we'll give that option. But if anyone, if you leave that option, then by default, India will be printed there. That is default constraint. Okay. Check constraint is basically, the data validation in Excel.
Yes.
What does it do? Data validation.
Data validation.
Hmm.
Based on the value we have entered, for example,
Hmm.
say value has to be entered from 1 to 10. If we go beyond that or any
Hmm.
other number in beyond that range or which is not in that range, it will
Hmm.
throw an error something like that.
Correct. Yeah. Perfect. Yes. Let's say there are marks and marks, least can be 0, max can be 100, then I cannot type 200 there in that column, right? So what is that we do? We apply a data validation rule, checking these conditions. The minimum should be 0, maximum should be 100, right? The same thing in SQL is kind of a check constraint. What is a check constraint? The check constraint ensures that all the values in a column satisfy certain conditions. It's as good as a data validation only. So the simple example is, let's say, what is the data type that we have given for this age column? You remember age column, which data type we used?
Small.
Data type. Tiny integer.
Small and
Yeah,
Tiny
tiny,
integer.
yeah.
Tiny integer, right? So tiny integer capacity is from what? 0 to maximum?
255.
255.
255.
Right. So because this column accepts up to 255, if I type an age 250, will it accept? Will it accept or not?
It will.
It will accept. Why?
It
Because
will
tiny
act.
integer capacity is up to 255. 250 looks to be okay for the tiny integer. But hold on, as an, from the business standpoint, okay, someone's age 250, is it looking realistic?
No.
No, right? So that means a data type can control, certain things like, in terms of getting the right type of data into it. But certain columns, they need to follow rules. Like age column cannot go beyond, let's say, 100. So if you want to set up that kind of a rule, that is what the check constraint does. Okay, but again, we don't need to worry about that. Someone who develops the database, they take care of all these rules. Okay, what is the check constraint? It checks whether all the values in a column satisfy certain conditions or not, as good as our data validation only. Okay, the other things are there. They are unique, primary, foreign, and index. Index is a quick thing only. We'll discuss that in the next session. But please make sure for today, you just try to create one sample database and just delete the database, see how it is working. Okay, and then we'll create our tables in our next session. I've requested for tomorrow 9 to 10 session. Anyways, we'll roll out a poll. If all of you are available, I'll take it. But at least 1 or 2 are missing, then probably we can catch up on Monday only. But yeah, I'm okay with the tomorrow's 9 to 10, and we'll soon roll out a poll. Please requesting you to please respond to that. Okay. So far, is it fine? Able to follow what's happening in the table design? We discussed column name rules, data type rules, and constraints. There are 4 more to be discussed. We'll discuss in our next session. Is it okay, everyone?
Yes.
Yes.
Right. So fine then. So please make sure you complete the installation and be ready for our next session. Yeah. Great then. Thanks everyone. I'll see you all. Bye.